these two balance one another out. So I think we can safely say that certainly for probably reasons that we weren't really aware of at the time this happened, but for one reason or another agricultural emissions have declined over time. The other issue that plays into this is the decline in the size of the sheep industry and drought. Obviously that affects cattle and sheep numbers, and that has quite a direct effect on the magnitude of the emissions from the industry. And I think that's one of the avenues we don't want to go down. We don't want the solution should not be we have less ruminants. I think the solution is we maintain a ruminant industry, but we do it more efficiently in relation to greenhouse gases. And this graph sort of feeds on from that a little bit. It just shows that over the last 20 years, the pink line is the emissions in million tons of CO2 equivalents from the cattle industry, and it's increased because the industry over that time frame has also increased. But what you can see on the blue line is that the emission per unit of saleable beef, carcass weight in this case, has declined. So the industry has become more efficient, and a lot of the reason why that's happened is because we're turning cattle off at younger ages. We are getting better breeding rates, we're getting better weaning rates, and all these productivity efficiencies which we're all striving for anyway, they actually go in the same direction as this methane story. So a more productive industry is one that has less methane associated with every animal you turn off the property. You know, in terms of scenarios, and you'll probably hear a bit more about this from some of the other speakers, but one thing I think is when this was something that was done by ABER about a year ago now, so probably there's been new data since then, but what it shows is on the left-hand side, the sort of greeny bars on the graph are the emissions under a business-as-usual scenario. In other words, we just carry on doing the same thing as we've been doing the last few years, and emissions will gradually increase over time until 2030 they've gone up from about 80 to about 90 million tons of CO2 equivalents. If the CPRS was implemented and had an impact on agriculture over that same time frame, the prediction is that there would be a decrease in emissions from around 80 down to somewhere around 70 million metric tons over that time frame. But what's interesting is if we look at then the graph on the right hand side is how that mitigation, how that reduction has been achieved, and the red bar indicates the improvements due to the intensity of emissions, so less emissions per unit product or whatever, per unit area. But the dirty green bar, decline in productivity and substitution, that really means less ruminants out there and more grain or whatever cropping, less ruminants. And I guess that's the part of the equation that concerns me, is we want more efficient ruminants, but we don't necessarily want less of them. There is a feeling out there that the solution is take the cattle out of the bush and put trees in there and we've solved the problem, and it's a lot more complex than that. And I think we really need to start looking at what are the complexities of that, what is a very simplistic solution, and when you look at it in terms of a whole range of issues, then you quickly realize that's not a solution that's open to us, thankfully. So just to put Australia's greenhouse gases into a bit of context, agriculture, forestry and fishing are a big chunk. They account for about 30% of the total emissions, and these values change year by year. I think the latest data shows us a little bit lower because of the recent decline in livestock numbers. But of that, straight agriculture accounts for 16%. It's now around 14%, and that's a mixture of increased industrial emissions and a slight change in agricultural outputs. It'll be interesting to see with the global downturn in the last 12 months how that affects the relative proportions, because people do get quite hung up about whether we're 15% or 14% or 16%. At the end of the day, I think we should realise and take account of the fact that agriculture is a big part of this greenhouse gas issue. And when you drill down a bit further, then you see that methane from livestock, and by livestock we mean cattle and sheep, is actually fully 2/3 of where these greenhouse gas emissions are coming from within agriculture. So ruminant producers are definitely front page news when it comes to how does the average Sydney householder reduce their environmental footprint. And if we put it in a little more regional context then, in terms of where it's coming from, Australia as a whole produced about 61 million tonnes of CO2 equivalents from its livestock, and about 3/4 of that comes from the cattle industry, and most of that is the beef industry. We have very few dairy cows, relatively speaking. But if you then look at a Queensland context, then nearly all the issue in terms of greenhouse gases from agriculture in Queensland is the beef industry, simply because we have such a large beef industry relative to sheep. So I think it is pertinent that we do something about it in Queensland, and that's one of the reasons why a lot of the research I do now is funded through the Commonwealth Government. They've realised that this is an issue that needs to be addressed. The Department of Agriculture have put significant dollars into trying to address these issues, and we're directly involved in that, and some of what I'll show you is some of the work that we're doing currently to try and get that figure looking a little less serious. You know, Northern Australia is a big part of the issue. Depending on how you define the north, between about 1/3 and 1/2 of the cattle are up here, and under current guidelines our cattle are estimated to be more inefficient when it comes to producing methane than southern cattle. So at least half of those enteric methane emissions are northern cattle industry, a lot of pastoral production systems in there. So it very much is focusing on the pastoral industry, livestock in the bush, and what we can do about that. When I've given these presentations before, I find that, there's a screen down here, I don't need to screw my head around any longer. We find that, I find anyway, a lot of people get confused. They say, look, this is a natural cycle. You know, cows eat grass, they burp, they fart, they respire, and it's just a cycle, and it's natural, and it's different to coal you dig out of the ground. And why are we being targeted with the same brush? And I guess, you know, this slide tries to explain a little bit what happens in terms of, it is a natural cycle, but there is a kink in this, and that's, you know, the devil is in the detail, really. But what's happening is cattle are respiring, they're grazing, as are kangaroos and other things, but cattle are also producing methane, and ironically kangaroos are, as far as we know, do not produce very much methane, and yet they eat the same diets. And that's an interesting question, and one where there might be a solution for the industry down the road, is can we put the flora out of the gut of a kangaroo into a cow and turn it into a non-methane emitting cow? And that's a long-term goal, but it's certainly one that's being looked at. But of all this that's going up into the atmosphere, of course, then the CO2 is being collected back by trees and grass or whatever, and resequestered back into the carbon cycle, but the methane isn't. And I've just gone on a little bit to simplify this down even more, because I think it is a question I get a lot of discussion around. So we have CO2 in the atmosphere, and 1 kilogram of CO2 has a global warming potential of 1. So the plants photosynthesize, they take the CO2 out of the atmosphere and turn it into carbohydrates in the grass or the trees or any other plant matter for that matter. And so that CO2 has been removed out of the atmosphere and stored in the grass, and then we graze the grass, and the animal takes that carbon in that CO2 and puts it into its rumen, and in the rumen then 2 things can happen. One is, what we want to happen is that energy in the carbohydrate gets absorbed by the animal grows, and that's what we want. But at the same time we have rumen fermentation, and you've got to realize this rumen fermentation is what we need so that cattle can actually eat grass. You know, if we didn't have the fermentation, we wouldn't be able to raise cattle out here, period. So we have to have that fermentation process. That's what makes, I think, our industry unique, is we are unique in the world that we can take a landmass that grows something that's not directly of any feed value to humans and turn it into high quality protein. And we can argue the case that you can't grow sorghum or rice or anything else in a lot of the land out here, whereas if you're in Europe or whatever, there is competition for that land base between ruminants and crops.